Welcome back to the Facit Homes channel and welcome back to our Facit Build series. And so, as you can see in this episode, we've been busy at work. We now have what looks like a full building. We've topped out the structure. We have windows, membrane and MEP going in. And so in this episode, we're going to walk you through the building for the first time. You can see the built structure and each of the rooms. And we'll also talk you through all of these key components of the chassis, the windows, the membrane, the roofing, and we'll make our way from the ground floor all the way to the roof where you can see the solar panels. So without any further ado, let's jump into it and have a look around. All right, so we're back on site once again, joined by Bruce, our CEO and founder. And we thought we'd do a little recap of where we are, right, Bruce?
Yep.
So if we go back a few episodes, foundations we were doing in February.
That's right.
We had the Microfactory deployed at the same time. The last time we were filming, we were here in May, full production mode of the Microfactory. Halfway through the structure, we were just about to start putting components on the first floor.
Yeah.
We're now here end of June.
Yeah.
And we have a fully topped out structure, membrane, windows in, and also the Microfactory is no longer in production mode.
That's right. So we're just getting ready to ship this off because it's no longer required. We've made loads of progress since the last episode. We've got all of the external kind of air and watertight stuff completed. Inside, we've got all the M&E happening in parallel, which we're going to have a look at today in detail. So yeah, really rapid progress. If you think really since February, just how fast it goes. And that's the kind of beauty of the overall strategy of the company, using digital design, contracting, manufacturing. That's what accelerates the process.
And so the Microfactory has really been here all of 3 months of production, if that.
Yeah. I mean, it arrives early just so we can set it up. And then it's been here for a few weeks just waiting to get shipped off.
And then, so we're going to go inside, we're going to cover some of the key things like windows, which have just been going on, the membrane that we have inside, MEP, and I guess for the first time, we're going to be able to give the viewers a tour of the entire house now that the full structure is there. Yeah,
it's looking much more like a property now. You can feel the spaces, you can start to get a sense of what it's going to be like. And we're almost kind of heading towards the finish line now with plasterboards starting to go on the wall, so it's going to get closed up quite quickly.
And so we're projecting to finish maybe before the end of the year.
Yeah, we're going to finish early. We're probably going to finish in October. So we're absolutely flying.
Shaving time off.
Yeah, literally. We had a contract date of December. We've got a couple of months off that because we're just streamlining things so quickly these days.
There you go. Unheard of. We're finishing.
Yes.
We're finishing early compared to the normal building.
Correct.
All right, Bruce. Let's touch on. First of all, what's this yellow stuff? Is this branding or is it, where does this come from? And then also let's talk about the windows. It's obviously a huge component of one of our products.
Yeah, so the windows were installed immediately as soon as the chassis was ready. So actually still we were doing manufacture of the chassis going up, but the window portals were ready, so the windows went in straight away. So this is from our window manufacturer Velfac. They're triple glazed, super insulated windows, aluminium outside, timber inside, and we'll have a look on the inside in a minute. And so what we can see here is 3 products. The Velfac window, the aluminium pod, and the air tightness and breather membrane. So starting with the breather membrane that goes on first, and this is giving us a waterproof jacket to the timber frame to protect it, but it also provides a high level of air tightness. So air tightness means that we haven't got heat and air leaking out of the building. It's what helps to keep it warm as well as the insulation. So this is all on taped. So the aluminium pod is our own manufactured product. So we have a laser manufacturer partner who takes our digital design files for every single window, which is different, straight out of our BIM production system. That goes to the laser manufacturer. They cut it according to the information that we give them, fold it and send it back. So here we've got the aluminium pod. It's got a little return detail, super waterproof, and then it's taped over at the back against the membrane. So it's one of the most robust window details to protect the timber frame is really what the critical part of this is. And all these 3 products are being designed to work together, and also really well thought through in terms of kind of installation process as well.
So a few key things also is that we're not seeing from here is the components, the window components are kind of made to receive the Velfac windows. this is, I guess, the interface kind of between those two that makes sure everything fits perfectly.
Exactly. So actually the tolerances are really, really fine. So we spend an awful lot of time understanding the tolerances between the window, the chassis, and the pod. And actually, we've actually tightened everything up just a little bit more than we had done previously. So really accurate installs. Tight tolerances means good airtight detailing, means you're nice and comfortable in your house. You don't have drafts blowing through, for example.
And so right now we've got, with these things, the roof, it's a fully waterproof structure right now.
Right now we're fully waterproof. Watertight means we can crack on the interior, and it's independent. So the cladding is starting to go on the outside, and they're now in parallel strands. So everything's separated from the cladding can do its own, have its own program. The roof trim needs to go on, but again, separate program. And the interior, which we'll have a look at, is on a separate program as well. So that gives us the flexibility to just get the project over the line.
All right, so we'll give you guys, this will be a little bit of a tour and explanation as we go. First time you guys will see a complete structure. So we now have a front door. We'll talk about that in a later episode when you can see it. But we're just going to walk you through the space, and we're going to go straight to the living room through here.
All right.
All right, so we're now back in that central living space, as I think in the last episode you saw. But a couple new things here. We've got fireplaces, the kitchen we'll talk about, but I guess one of the main features is the stairs, which is completely new. Maybe talk about that. It's also made by us, right?
Yeah, so the stair is really part of the chassis for us. We do it using the same digital information, using the same production. We get it in exactly when we need it. So here, it's all spruce structural graded plywood. You can see it's manufactured with the balustrade up here. You can see that's the underside of the stair just coming over as well. It's a parametric product, allows us to adjust the width as desired.
There's typically kind of two types of stairs that we do, right? So this one is made from the chassis. It's maybe what we call a more discrete staircase.
Yes, correct.
But we also do feature staircases where you're fabricating laser cut metal, all that kind of stuff.
Yeah, so quite often, well, some of our projects we tend to do something more fancy. These kind of feature staircases. This is more the discrete style, because actually here, the upstairs is a bit more of a private area. So it's not such a feature. You know, the customer is really, that's their private quarters, if you like. So this one is just a simple timber stair with a plasterboard covering.
Other key feature in this space is the fireplace. I think last time we were here, there was just the two pillars, but now we have a fireplace, right?
Yes, so we've got a double-sided fireplace here, which is glass both sides. So you can see the fire from either side. This is a bioethanol fire, which gives off the flicker, but it doesn't give off too much heat because the house is super insulated, so we don't want to have a fireplace that gives off too much heat because it'll just get too hot. So here, a gentle flicker, bioethanol gives off a small amount of heat but keeps the effect of the fire.
Other key space that we have here is, of course, the kitchen. And I think this space really illustrates the way the chassis and all the MEP, for those of you who may not be familiar with, that's mechanical, electrics, plumbing, all that kind of stuff, which you can see fits almost perfectly into all the spaces. We're using the channels. Maybe talk a bit more about this stuff.
Yeah, so a really big part of the design for us is the coordination of all of these things with the structure. So here you can see there's these ducts for the heat recovery system. They're quite big, and if you get them in the wrong place, they will clash with your structure and your beams won't work. So all of this is modeled in 3D exactly in combination with the beam structure to make sure it's really well coordinated and we don't have any clashes.
Let's maybe touch on how the chassis works with some of this stuff. Like we have vertical gullies, horizontal gullies. We touched on before, but now we can actually see it being used.
Yeah, so here you can see we've got a horizontal service channel distribution for hot water or power. We're getting up and around windows. We can see here, these are the sockets above the kitchen counter with a service channel that's at the right height. So we're not having to put additional layers of battens or packing it out. It's as efficient as possible so that we've got as much insulation and we don't have just kind of continuous layers of air, essentially, that don't give us any value.
You can almost track it perfectly from here, and then it goes into the verticals, into the beams, and connect off upstairs.
Yeah, correct.
So, I mean, this space we've not actually shown in the last episode, but just talk to us. We got here is the
So this is the kind of dining area. So the other side, that's the kitchen on the other side of the wall. Here we've got a dining area and we've got the fireplace both sides. In here, there's going to be a big glass pivot door, and this room is much more private. So this is their private lounge, which is at the end of the building, kind of closed off from everything. So a bit quieter, but still easily connected to these main spaces. And then here we've got some very big sliding glazing panels.
Yeah, I mean, these are incredible windows.
Yeah.
Incredible size. And again, you can see all the pieces coming together, the windows, the MEP, everything kind of sitting together.
Correct.
Maybe another good feature to touch on is this is our interior wall.
Yeah.
But now it's full of insulation. Maybe talk us through what that is.
So the walls themselves are parametric, so they can be any depth that we want depending on what's going in them. This is the kind of narrower depth because it doesn't have any services such as like drainage pipes, etc. running through it. So here we've got 150 mil, we've got acoustic insulation, which just protects sound from one side to the other. On top of this we'll go 15 mil plasterboard. They're very solid, they're very acoustically separated, so you get really low sound transmission between rooms, but also between floors as well. So there will be acoustic insulation going in the ceiling structure here as well, between this floor and the next. As well as other things like resilient bars. So there's lots of details that are really well thought through to minimize sound transmission in a very robust structure. So they're more robust than, for example, a traditional timber frame, which tend to be a little bit more lightweight, tend to have a lot more sound transmission.
Yeah. So you have a nice soundproof Facit house.
Yeah.
First floor. Last time we were up here, there was no walls or anything. We were pretty much standing in around the same spot. Yeah, talk us through this amazing void space we've got here.
Yeah, so this is the double height space, letting light flood into the center of the plan because it's quite a deep plan.
Yeah.
So it really just lets light go through into the corridor spaces below. So as soon as you come into the building on the ground floor, it feels really light. We're going to have a glass balustrade across here, so really minimal, nice detailing. But you can also see up here we've got the boarding on the floor, which is concealing the underfloor heating system.
Layout wise, we got 2 bedrooms to the right and then the master suite and some bedrooms to the left. We'll maybe go check those out.
Yeah.
So here we're in what I would call a complete Facit room.
Yeah.
We've got like stuff going on the roof. We got MEP coming through, but a closer look at the windows from the inside, because these are pretty incredible spaces. You can see we're both over 6 foot and you've got good height of space. Maybe talk about the windows from the inside.
So this is the Velfac window. So Velfac are our partner and have been since 2010. We get amazing prices for a really, really good quality product. So we've got our timber reveal on the inside, so quite a deep timber reveal. Triple glazed panels. Here you can see a side opener as well, so a side hung opening. And on the installation, we've got unique installation details which give us high levels of air tightness. So super airtight structure. And then actually the beautiful thing about the Velfac windows is that the frame opens from the outside. So they don't have a frame within a frame for windows that open. And the nice thing about that is we'll plaster in. So the plasterboard will come over the frame into here. And from the inside, all you see is glass. So you don't see a bulky frame around your window. You just have really beautiful glazed opening. And so we spend a lot of time thinking about these exact small details, how these little trims are going to be fixed and how it's going to be really well resolved. So these kind of interfaces are the things that we really sweat and we think brings value to the overall architecture.
It's almost seamless windows, no frames from the inside almost.
Yeah. Also here you can see we have the downstand here, which is our little mini service void for our flat roof structure. So this is just enough space to give us the downstand for low profile recessed ceiling spotlights. And you can see the cables are run in the channels that we've allowed for it. So it gives us that kind of design freedom to put the lighting wherever we need to, but also maintaining all that insulation above it and just separating out the insulation from the electrics from everything else.
Maybe talk to us about, we've got the wires in. It's called First Fix. What is First Fix? What does that include?
Yeah, so First Fix is all the stuff that you don't see, all the stuff behind the wall. So the cables, the pipes, the lagging, the insulation, and that's the stage that we're at now. And we're almost finished the First Fix. So The cables are in place for the lighting, the plumbing is in, the air conditioning, we'll have a look at that in a second, is all in. So you can see, actually you can see over here, there's some plasterboard ready to go on the wall. So very quickly, this building will get closed up, all the board will go on the walls, and suddenly it will be completely different. It will be much brighter, it will be acoustically different, and it will start to feel even more like a completed project.
And then next time we come back, we should be talking about second fix.
Yeah, so next time we'll come back, we'll talk about second fix, which is all of those final fixtures going in and the connections between the lighting and the wiring and the cisterns and the sinks and taps and all that stuff to go in. So at the moment, we're just putting in the infrastructure ready for all that other stuff.
One other thing that they won't see on camera here, but these are being filled, right? All of the holes are closed.
Yeah.
Maybe talk about the insulation there.
Yeah, so there's behind this little piece of tape, there's a small hole. The insulation gets blown into this hole. So they're a kind of closed box. The insulation is a bead insulation, which gets blown in with a bonding agent. So that gets blown in. We've got 280 mm of insulation behind this surface here. So passive house standard thermally insulated components. Blown in, really clean, really quick, and separated from the services again. That allows us to be able to do all these things in parallel and not have to have people pulling insulation out to run a cable and pushing it back again.
Another part we haven't really touched on, well, we touched on a bit, is the MVHR units. We can also see like the electrics above are just pristine in the right places. Yeah, maybe talk about how we heat and cool the building.
Yeah, so we've got the MVHR system here. So you can see these are ducts. So they go all the way down to the ground floor to the plant room where the MVHR unit is. So there's one here and there's one here. You can see this one is just behind this insulation. It's pointing out here. And it's confusing because it's called a mechanical heat recovery ventilation system, right?
Yeah.
A lot of words. Basically though, it's a fresh air system. So confuses people because it's like, does it heat? It doesn't heat. All it does is it brings in fresh air, circulates it around the building because the building is highly airtight. So we want to feel fresh and comfortable. The heat recovery bit is just, what it does is it maintains the heat in the air. So rather than the heat just being chucked out, it keeps it in the building. So that's the kind of heat aspect to it. The heating is actually provided by an air source heat pump, hot water system that circulates around underneath the floor. So they're interrelated, but they're separate systems.
I guess the key concept to understand is most houses that people live in, they heat the building up and it just pours out of the roof or the window or whatever it is. Ours is highly insulated. So first of all, it doesn't pour out.
Yeah.
Which then also means that you only need to heat it up a little bit, and then the rest of the game is keeping it inside, the envelope.
So in this property, we're really close to Heathrow, and Heathrow is a heat island. It's all this tarmac and surfaces for the airplanes, and what it does is it radiates heat out for quite a big area around it, and we're within that heat map. So one of the things we've had to do in this property is, because we want nice big glazed windows, is fit air conditioning. So the air conditioning is only in the rooms upstairs, so the bedrooms, and here you can see all of the pipe work for the air conditioning unit, which have all been designed in 3D, coordinated with the structure. You can see it's coming through here, and you'll see it actually distributing out in various different directions throughout the house.
And so you'd have, here is going to be like that wall-mounted kind of system.
Yes, somewhere in this room will be the wall-mounted system. Yes, you're right, it is there, because you can see the actual cables coming out through the wall. So there'll be a high up on the wall, a small, quite sleek air conditioning unit.
So we've made our way almost from the entrance to the corner of the building. This is the master bed bathroom. And one thing we haven't talked about as well is another product that we make in the chassis, which is the bathroom boxes and how that works. Maybe talk us through that.
Yeah, so bathroom boxes solve the problem of carpentry detail design. So we've got to coordinate the cisterns, the taps, the pipe work, and things like mirrored cabinets. So there's a mirrored cabinet going in here, and there'll be tiling on here as well. So the critical thing is, how do we make sure these are all exactly right, so that this is really perfect for the size of the mirrored cabinet going on the wall. It's not too small or too big. We don't have to do any kind of fixing carpentry work because it's been put in the wrong place, which tends to happen with the traditional carpentry processes. So the bathroom boxing it has these kind of scooped details on the actual structure here that allows the services to run through. So it's a product of ours that just is suitable for the bathroom to get all of the services in that we need. Here you can see we've got drainage pipes, we've got hot and cold water running, we've got feeds coming out for the sink, this is the actual fixtures for the tap fittings, so there's a bath going here. And then actually on the other side, just behind you there, Ollie, there is the system for the toilet, which is wall mounted. So again, we've just left the perfect amount of space for that to fit in. Everything's really well coordinated. And, you know, the reason that we do this is because it accelerates the project. You know, it just means that we can crack on, and that's why it's moving so quickly. You know, although you could build all these things in traditional carpentry, it's a slower process. So a lot of what we do is how do we speed up the traditional process of construction using digital design, digital technology.
There's very much that parallel analogy of the car chassis. You know, we've made our chassis, and all of these parts, the wheels, the electrics, just fit into place. I think the bathroom kind of sums that up the most clearly.
Yeah, and I think that's the thing to remember. You know, when you talk about the chassis of a car, it's ready for all the other components to fit to. That's what the kind of nature of it all is, and that's the same with our chassis. So here we're looking at one of the skylights. So this is a very simple Velux skylight, power operated to allow ventilation through the building up to the top of the house. Perfectly formed within our structure. Cheap and cheerful. You know, we're not spending loads of money on a fancy roof light. It's just off the peg, standard stuff to mix in with the blend of other stuff that is more customized.
So we just touched on the inside about the heating and cooling of the house, but we also have some measures on the outside for cooling, the shading aspects. Maybe talk us through what these are.
Yeah, so on the outside of the building, we've got quite deep, like 1.2 meter deep shades to protect the windows from getting too much sunlight through them in the summertime and overheating the house. So this is the first part. So it's a two-part system. This is designed by us, manufactured by us. Two-part system. This is part one, which is the kind of bracket. And then part two, which will go on when the cladding is in, is the actual shade.
Right.
So what we can see here is quite a large aluminium bracket and fixing. So you've got bracket, fixings, and this is the bit that's going to receive the actual shade. You've actually got integrated into it is the first blade of the shade.
Yeah.
It has to be really well coordinated. Tiny little details here to get around the window pod of the actual window below. You've got laser cut numbers cut into them to identify the parts.
That's
you can
super
see
nice.
there on the sides. Really precise tolerances, and yeah, they're a really, really good product. This is actually probably the fourth version of this particular product that we've done. So each time we've kind of iterated. So there's quite a lot of design changes that we had to do for this one to keep costs down. So there's a lot less material in this one.
So again, another product that we design, we manufacture through third parties, but we're, you know, it's basically our products. And so maybe to give you an idea, 1.2, I mean, it would literally come up to about here.
Yeah, that's right. Yeah, so
and
they're quite deep.
Maybe to explain the philosophy of that. So the idea of the shading devices is in the summer when right now the sun's very high up in the sky, it shades the window. In the winter, it actually lets the sun in, so it heats up the building.
Yeah, that's right. So the sun comes down at like a 60-degree angle in the summertime. That's really what we're trying to protect from. We actually want the sun to come through in the wintertime when it's a slightly lower angle, so that we actually benefit from the warmth of the sunlight in the winter months.
Free heating from the sun.
Exactly. This is the edge trim of the roof system. So it's actually an aluminium edge trim, really slim, 63mm. Again, just gets the roofing finish really quickly. This is the corner piece, and it sits over the main membrane, and then there's a taping system that just gets it all nice and sealed, weather tight. We've never had a leak, ever, using this system. What we've got here is a few things that are getting ready for the cladding to go on. So we've got Behind here is our ventilated layer. You can see these holes which were cut in the chassis, and actually if you look inside them, you can see holes within holes. And this is a big ventilated system that just allows free flow of air underneath our flatting roofing system that just prevents issues with moisture over time. Here you can see these, the timber battens which are going to receive the cladding system, which on this elevation is a render system. And then very fine tolerances down to the head of the window below. Here on the head of the window below, you can just see a little upstand in that corner. Again, that just guarantees that any water that gets behind the cladding will come down onto the aluminium. It won't go behind the cladding and just drip off that front edge. So really, really tight weathering details. Just means we never have to worry about water ingress.
All right, we've made our way to the roof.
Yeah.
We're now fully waterproof structure. Maybe talk to us about what is the roof made of. I know we touched on some of these details in the last episode, but now we can actually see them, the guttering. Yeah, talk to us about the roof.
Okay, so this is the roofing membrane system, which is a fleece-backed EPDM system. It's a synthetic rubber. It's got a fleece backing to it. It's really tear resistant. It's only a couple of mil thick, and it goes straight onto our building components. So as soon as the building components are in, this goes straight on, cold applied, no hot, no heat, no fire risk, and it adheres to what we've got. And you can see, actually, we talked about it in the last episode,
right, the
gullies. So there was, we actually looked at this piece here, which has got a gentle fall, and here you can see. So this piece is falling at an angle to here, and then this piece is falling that way out to the actual drainage outlet at the end. So incredibly precise falls on the whole thing, which actually, as a carpenter, to measure 1 degree fall, it's actually really difficult. Whereas the digital design does it, you know, instantly with no effort whatsoever. It can calculate these really precise things. So we spend a lot of time just modeling these things, and actually what you get is a very low profile. So on this front edge, it's very, very slim, and it just keeps the whole thing quite low, with all the water falling to here and then all the water falling away.
So it's technically not a flat roof. It's got that very slight gradient to it.
Yeah, all flat roofs need a slight gradient. So you've got to have a way of getting the water off it. So even all flat roofs, you can't have them absolutely flat. So they've always got a slight gradient.
I think that's the fear people have, is that a flat roof is just completely flat and it gathers the water, but there's a lot of really intricate details that we build into this.
But you can kind of just see it, you know, you can see the real crisp quality to everything that we've produced here. It's just so precise, and it instantly says something about the way it's made. You know, one of the best products we have is how good we are at doing flat roofs, weirdly.
Yeah. So now upstairs we get to see the other side of the skylight, our Velux skylights. Maybe talk to us about this. I see an interesting little sensor there.
Yeah, so really simple product, Velux flat roof domed roof light. This is the power operated version. So there's power to allow ventilation through the property. All 4 of these are power operated, so they just lift up slightly. And actually what this does, what this is a rain sensor. So if it rains and it's open, it senses it and it closes. Simple as that. So as an occupier, you don't have to worry about rain coming through your roof light. Leave them open in the summertime, happy days.
Very much needed in the UK.
Yeah.
Because it can rain at any point. Finally, of course, solar panels. This is something we get asked a lot about, is do our houses come with solar panels? Maybe talk about that as an option, and you know, how much this is going to actually power this building.
Yes, so we've got a PV array on this property. I would say most of the properties we're building at the moment have a PV array, some with a battery, some without. This property is going to have a battery to make the best use of the power generated. So what we can see here is a system that's ballasted to allow it to go onto a flat roof without penetrating the flat roof. So very simple. They put the system down. There's a whole bunch of breeze blocks under there, giving it some weight. And this will give us, in the summertime, a really high proportion of all the energy requirements of the property. The battery is the most important thing because it allows you to store the energy that you create during the daytime, particularly if you're out working. You know, if you're out working, you're not using much power during the daytime. When you come back at night, you really want to be able to use that power.
So the combination of this and the efficiency of the house, you know, you're almost going to be at a net zero
Yeah,
energy
absolutely.
output. The solar panels don't come with every one of our products, though. It's a client's choice, right? Maybe explain that.
Yeah, so the PV panels are customer choice, they're an upgrade. So not everybody has it. What is included in the house is all of the heating, the air source heat pump, which is already highly sustainable, the building envelope being airtight, super insulated, triple glazed windows, that all comes as standard within our base price. This is an upgrade that the customers choose or choose not to take.
Thanks again once for joining us on our Facit Builds series. As you can see, we're making extremely quick progress of the Walton project. Join us for the next episode where we're going to be coming back and talking about the cladding and also some of the interior fit outs with the next phase of the builds. As always, if you're thinking of building your own sustainable home or would like to get in contact about a product that you have, reach out to us at info@facit-homes, or you can go to our website and under the contact form, fill out the form and you'll get through to one of us and we'll get back to you to talk about your projects. If you like this episode, simply give it a like and a subscribe so you can share it with anyone that's thinking about building their dream home. Otherwise, we'll see you in the next episode.